Question 7 asks us, which expression is equivalent to the expression given, x to the fourth minus 8x squared plus 16? There are a few ways to do this question, and no way is better than the others. It's really just a matter of preference. My personal favorite way of doing this involves a pretty neat trick, where you introduce your own variable and you substitute it for x squared. We'll see how this works out. Let's make our own variable, maybe we call it u, be equal to x squared. We can then rewrite the expression that we're given in terms of u squared minus 8u plus 16. So why did we do this? Well, the reason is because we don't have a neat way for factoring fourth degree polynomials, but we have a really neat way for factoring quadratic polynomials. By rewriting this expression in terms of u, we've turned a fourth degree polynomial into a quadratic polynomial, and we can factor this much more straightforwardly. We're looking for values that multiply to 16 and add to -8. Those values are -4, -4. Factoring this into u minus 4 times u minus 4, and then substituting x squared back in for u gives us x squared minus 4 times x squared minus 4. But we're not done yet, because both of these binomials are also the sum and difference of squares, x plus 2 times x minus 2. Lastly, we can simplify this by combining the like binomials, giving us x plus 2 squared times x minus 2 squared. There are other ways of doing this problem, as I've mentioned. One pretty straightforward way of doing this problem is to simply plug in a value for x, evaluate the expression given, and then plug that same value into the answer choices to see which answer choice yields the same value. For example, I might say x is equal to 2. So the expression given is therefore equal to 2 to the fourth minus 8 times 2 squared plus 16. You can compute this relatively straightforwardly, even without a calculator. You have 16 minus 8 times 4 plus 16, which gives us a value of 0. We would then take that value, 2, and plug it into x in the answer choices, looking to get 0. While this is the most straightforward way of approaching the problem, it can also be a little bit time-consuming, since you might find yourself having to check every answer choice before you come across the right one.